And welcome everyone to today's webcast titled Supercharge Your FinOps Tool Investment with Optimization. Now this title is it's always of great interest. This is a rerun of a session we did a couple of months ago, because people often equate optimization of infrastructure with FinOps initiatives. Are you not optimizing if you have a mature or emerging FinOps practice in your organization? And in our observation, no. We're going to talk about why and how what we do at Densify might be something you would consider augmenting your practice or your FinOps procedures or best practices or governance with. So that's the topic for today. The event will be recorded, so if you want to share it with your family and friends, you'll be able to do that. We'll send it out after. I think it's usually next day or so after the event. We do have Q&A open. You can enter questions at any time if you have questions on the fly. I can't promise we'll interrupt our flow to answer questions mid-flight, but we'll certainly take them at the end of the call, and we'll leave time for that. We also have 2 or 3 audience polls, one to keep you awake, and 2 to just capture a bit of info from you and get your opinion on what's important or how you prioritize. We do have one at the end as well, where we love to hear from people, just why they attended our session today, so that if there are things we can do to do content that is appealing, we are able to do that. So that's enough of the administrative. I don't think I forgot anything, and we'll get right at the content. With me today is Andy Walton. Andy is going to cover the demo part of the programming, and I'm going to cover introductory slides and take you through a few themes before we get to the actual demo part. Because we do like to show, not just talk and put up pretty pictures. So just a word on, as we've observed, because we've been in this business for some time, the Densify, which I will introduce to you, has a deep history in optimizing data centers. And how that's changed over time is we've moved from virtual to cloud to now container infrastructure. Of course, most large enterprises, most of our customers are doing some of all of these things. But we've observed that as the shift to cloud has picked up speed and now containers and container infrastructure are becoming very popular, the complexity and the number of elements that you need to optimize against are becoming much more complex and numerous. In the days of VMware and virtualization, you could control your central purchasing of your hardware, you could manage demand, generally was much more encapsulated on an enterprise basis. Cloud introduced a lot of what we call micro purchasing, the ability for organizations to enable a variety of distributed individuals to make selections on capacity, to take advantage of the flex up and down of cloud. In some of our customers, there may be hundreds of people that are making these selections. And then as we go to container infrastructure, even more granular, even more subdivision of the way you manage the resources and the capacity at the node, at the container, at the scale set, replica set. The complexity there is really large, and it makes the decision-making around capacity much more difficult. And we've observed that with cloud, there was this gap and a big focus, thus FinOps, on the bill and the finance side of the equation. We see a need to return to more formal, we call it here loosely, capacity operations. It's the observation that to contain cost and risk and make sure your stuff performs well, the infrastructure resource decisions really needs to be driven by software, not by humans making the best efforts they can. And we'll talk more about that in the next few slides. If you contemplate cloud cost, and we'll throw containers in the cloud into this bucket, the cost equation is a very simple one. One is, of course, you need to make sure that you're getting the right discounts, that you're making the right commitments so you get the right discounts. But your consumption, what you actually select and use, is really the biggest single determinant of your overall cost, because price needs to be multiplied by quantity, of course. It's a very simple thing. That drives out your total cost. Now, when you look at who is responsible for what in this equation, there is a whole lot of stuff that finance has to, and procurement have to concern themselves with. They have to understand the spend and who's spending what. You have to understand how you're controlling it and apply those controls. You want to be able to detect anomalies and make commitments on behalf of the organization so that you get the optimal discount. If you say to AWS that you commit to buying certain amounts, almost like physical servers, they'll give you a better deal. So you better do that. But when you get down to the actual selection of your capacity, the specification of your resources at the container level, things like automating the management of these environments, and integrating it to the processes that put new workload into these environments. This is not the domain of finance. It is the domain of the app owner and engineering and platform owners. And so if you look at a recent survey, one of the big challenges, this is from the FinOps Foundation, polling their membership. Some of you may be members of the FinOps Foundation. The biggest challenge they've observed as part of FinOps is getting engineers to actually take the action of optimizing. And it's because of that delineation that we just talked about that this is a challenge, because app owners and operations really care most about performance. They're aware of and understand the importance of cost, but not at the expense of performance. They have to meet the needs of the business. Finance and procurement are almost the inverse. They understand the need for performance, but it can't be done in a wasteful fashion. So the control and the concerns live in very different places. App owners don't want to change stuff that's working well. Doesn't matter if it's over provisioned. It's easiest to leave things as they are. So there's a natural factor here of just wanting to keep things the way they are. And then the third is that it's very difficult to do these kinds of optimizations at the resource level at scale. And certainly finance can't do it, procurement can't do it, because it relies on the people that own the infrastructure. So these are the challenges. Now, if you think of this in the context of your process, where you write code, you merge it, you build it, you deploy it, you put it into whatever your infrastructure of choice is, that results in a cost flow, a billing action to finance. And channeling Bart Simpson, ay caramba, that's expensive. Let's go and buy some RIs and savings plans to get our price down. That's the lever that finance has. There is a big chasm between the lobbing of the bill to the people that actually could control it and the people that have to care for the spend. So nobody on the app owner or cloud engineering side really wants to be told they need to make a change to infrastructure, because for all the reasons I just mentioned. So something is needed to bridge this gap. You can be really buttoned down on your FinOps, your control of billing, cross-charging, making people think about the bill, but to actually impact it, something has to bridge this. We would say that it really has to be driven in an automated way. And it's not that we're prescribing that infrastructure is actively responding on the fly and sort of in a mysterious and out of control way based on some algorithms. It's about automating the process of bridging that divide, getting rid of the divide and having everyone working toward it. birds chirping and bills smaller. So if we think about a lot of the FinOps tooling, and some of the logos are here, these are great products. They do a really good job of solving generally the needs of finance teams and procurement teams. Some of them are even, free by the CSPs, the cloud service providers. The DevOps tool chains, the way we build software is always changing. It's faster, releases are faster. Those tool chains are, evolving and highly adopted. The gap here is in this attendance to resource and instance optimization. So let's throw a poll on this topic out to our attendees. And Daniela, can you throw that up? Just a question for everyone. If you look at your public cloud spend and the consumption thereof, how are you doing that today? I always like watching these come in. Hopefully people are participating in the vote. There's a good number of people on.
It won't let me vote, Chuck.
Good. And identified people should not vote, including you, Andy.
Yeah.
So a pretty good distribution here. Not surprising to see free tools being an important thing, because the capabilities of those free tools are, getting better over time. Someone saying none, but we don't see a lot of that in larger enterprise. So thanks for that input. Sorry, I shared results. Probably you were supposed to do that, Daniela. I can just move that out of the way. Okay, so thanks for that input. So what is Densify? Densify is an engine that focuses on the specific requirement of deciding how much resource for those workloads so that you are balancing performance and cost. That is all we do. We're not, we don't go and dissect the bill or distribute the bill or handle the cross-charging. We handle the challenge of filling this gap, which is replacing human effort and guesswork with precision analytics, and when you're ready, automation of the application of those analytics back into the infrastructure. That's where we fit. So this engine is constantly solving for the union of the instance requirements from a performance and scalability perspective, scaling where appropriate, with always an understanding of how you're actually buying the stuff and who you're buying it from. The difference is for us that we really, instead of starting with the bill, we are focusing on the behavior of the applications, the demand patterns to a very, very detailed level. We don't dumb anything down. We see a lot of the free tools, they'll look at 15 or 30 days, some of them a little longer, but they're very basic in the way they examine the workload. So that's the first limitation that we overcome by keeping all the history. Some of our customers won't make a decision unless it includes their historical data, includes the, for instance, this season, the holiday season. We are constantly feeding updates into the engine around the capabilities of the infrastructure, the performance benchmarks, the cost models, the technical constraints. We're working closely with Intel, and I'll talk more about that in a few slides, or actually at the end, to improve the accuracy of those benchmarks specific to certain types of workloads, for instance. And that's very important, because if you understand the deep detail, the need of the resources of the applications, their time of day, day of month, month of quarter, all of their behaviors, and then you also understand the capabilities of the infrastructure, you're in a better position to then add the billing data, an understanding of the billing data, add any other constraints that the business might want reflected, jurisdictional requirements, security requirements, those sorts of things. And then on top of that, add a policy engine that allows you to say what is fit for purpose for given workloads. They're not all the same. They're not all the same with respect to price sensitivity or performance sensitivity. That's what gets reflected in policy. So it's the combination of the deep demand patterns and our very granular policy that really makes our engine precise enough to then drive both performance and stability recommendations and cost and efficiency recommendations. And we're very specific in calling out the two of these. If you run around and only ever talk to your application or infrastructure owners about how wasteful they are and never bring them any value from a performance and stability perspective, they will talk to the hand. They don't respond purely to that. You need a balanced approach that says, hey, we're going to tell you you should upsize, modernize, or change family on some instances, even if it costs you more, because your application needs more or needs different. Or, hey, Intel working with us has shown that if you're running that kind of workload on AWS, you should be selecting a completely different instance type to get the feature set out of their CPUs. Those are all changes that would happen totally independent of cost. Then we'll tell you whether any of it should be done in order to save money. We'll deal with the automatic scaling and those sorts of things and how you're going to address that part, often a huge cost area. So this is the type of stuff Andy's going to show you in the demo, the specificity and the accuracy around all these types of changes. If we jump to container resources, similar concepts, but down to the very, very deep level of the container requests and limits, the detail around making infrastructure run efficiently and perform. Containers are a big problem because people think of them like VMs. And in VMware, it's wonderful technology. It allows you to do things like overcommit. Containers don't. You set at a developer level your request for CPU and memory. That is a hard request. We're seeing huge, I said it twice, over provisioning in container infrastructure. Let's jump to an attendee poll as we roll toward our demo here. What's the next question we have? Right sizing recommendations. What are you doing with recommendations that you get today, however you're getting them? Are you applying them automatically? Are you putting them through a change control process? That is it. What we're seeing here jump to the majority is a whole lot of hope. This is skewing almost perfectly toward our theme today. Look at that, Andy. Informing application owners and hoping they'll take action.
And I think to your point a little earlier around the types of recommendations and things, like the one thing app owners are going to need is the proof as to how this is going to make their lives better, and making sure that their app isn't going to fall over if they make a change to it.
I bet you'll show some of that in the demo.
You got it.
What would this look like in practice? If you believe us that our engine is accurate and that you can go and action what Densify says, we drop it into the environment, it learns and analyzes. It produces the optimization actions, but as well, both the machine readable output, that if a machine wanted to go and make a change, it could, and the human readable, to Andy's point, that allows them to agree that these things should be done, and those resources are optimized. Now, the purple T there, if you're not familiar, is Terraform. It's just an example of an actor in a stack that can make these sorts of changes. That's not to say that we aren't going to send it to Jira or ServiceNow, for a maintenance window or an approval ticket, because at some point, if people are going to allow, as reasonable people, reasonable changes. So the proof allows the app owners, when they are pinged, to say, yeah, we will allow that to happen. And the machine readable allows it to go back into a more automated process. that gets applied back to the infrastructure, which ultimately means that the bills that show up in your FinOps process are lower, and that finance says, okay, I'm comfortable that our costs are reasonable. I'm not going to play this share and hope game. I've taken care of it, or we have taken care of it as an organization as a regular process for managing infrastructure. And that's kind of this is the birds chirping approach. Most of our customers will get to optimization actions. They will live with them for a number of months. They will socialize them. They will share them. One department that's particularly anxious about their cost will say, I'm ready to start doing these things. I need to. My budget is constrained. A month later, wow, things are still running. In fact, things are running better. There's a case study on our website by Autodesk where they talk about an app owner talks about receiving a recommendation of an instance type he didn't know existed. He made the change. His bill went down. The stuff performed better. It's a great example. So this is kind of this sort of virtuous cycle that says policy compliant optimization actions, transparency and evidence builds trust, gets approvals, changes can get executed, quantities are appropriate, purchases are optimized. It's just the way it happens. If you were running a supply chain building anything and your raw materials cost went down, you would call that, more optimal. So let's jump to demo. What Andy's going to show you is how we take through this engine all of this raw utilization data. We apply machine learning. We predict into the future what the operational patterns will look like. We normalize everything so that we know if something is behaving a certain way on one class of infrastructure, what it will look like on another class. And we generate against those normalized catalogs and the policy that says this is what is right for this business unit or this application, this SAP farm, whatever it is, that it's okay to go and make this change because it ticks all the boxes. That's what Andy's going to demo. So I will stop sharing if I can find there we go, and hand it off to you, Andy.
I will share here. Let's see.
A reminder, if anyone has questions, comments, even text-based applause, we're happy to have it. Okay, here we go.
Let's make this a little bit larger. Sorry about that. This, I love it. The Zoom continues to get in the way there. There we go. That's better. Okay, so let's go through this. I think you've got a couple slides left and we want to leave some time for questions. So let's talk about maybe a 12-minute demo.
Yeah, just a few slides. And we are aiming on I didn't cover this. I think it's a 45-minute time slot. So
yeah, so we've got a little bit of time. So once we've collected the data, and again, it's a full agentless approach. It takes advantage of APIs through the cloud, for the different cloud providers, AWS, Azure, GCP, and your Kubernetes infrastructure. We'll gather that data. In some cases, it will gather, even up to 60 days worth of history and present the results to say, how well are you doing? So from a high level on the cloud side, I'm going to show a quick view of the containers as well, but let's focus on public cloud for now. It will give us a quick summary of what we're analyzing today across the 3 different clouds, how well you're doing in terms of sizing that infrastructure today. You want that green bubble, the optimal side, to be as large as possible. In this case, there's a fair bit of savings opportunities and a little bit of risk identified in. And that's the example that Chuck was using earlier, where you might have to give something more resources, pay a little bit more in order to meet a service level. And then before, after utilization of some of the key metrics, is saying how well are you going to be utilizing that infrastructure if you make the changes. And across the top in the bar here is giving us an indication as to what's the impact of the potential changes through optimization. So as you can see, it's more than just visualization of who's spending what. I'm going to show you some of that in a moment. It is also the opportunity of what's going to happen if we take those recommendations. In this case, an impact of around 37% of the monthly cloud spend in the areas that we can impact. Clicking on the little data tab here, you'll notice, and what I'm going to show here is, this is broken out right now by account. You can see across the top that I can use these filters to drill in. So I've got a fair bit of data that's showing here, and I can use any of this, these filters or group by and say, let's look at this from a different logical perspective. A lot of times our customers want to look at it, who's the owner of this infrastructure, because I want to talk to some of these people. So this is broken out now essentially by the owner. Efficiency rating, I just wanted to cover this. This is important. Efficiency rating is essentially a rating that we apply that says, if you've got a high number, essentially 1 is perfect. And that just means that your environment is efficient. If you're below 1, you've got savings opportunities. If you're above 1, there's potential risks in the environment. You've undersized stuff, and you might want to deal with that just from a performance and risk perspective. So a lot of times we'll look at this number and say, let's have a closer look at how well these folks are doing sizing their infrastructure. So efficiency rating is a good way to actually have a look at that. You can sort on anything using this this interface. We can use the filter to say, just show me as an example stuff that's running in Amazon. And so let's drill into that. And what I'm going to do actually is, and actually one other area that's important as well is just say simply looking at what's the dollar impact. So who do I want to go after first because they have the most potential money lying on the table, so the highest potential net savings. In this case, I'd want to go and have a word with Max and have a closer look at some of the infrastructure that's running here and what those recommendations look like. What I'm going to do is just drill down a little bit further here. So, possibly, and this is how someone would use the interface to potentially drill down a little bit deeper into the optimization recommendations that might apply for this set of owners. And I want to drill into, say, the infrastructure that's running using the mobile application. So I can get to any of the specific recommendations. You can see just from a high level, the ability to view the infrastructure in terms of where the cost impacts are. So a lot of customers like that ability to drill in. And then to actually get to the recommendations, here's where the rubber meets the road. And we've got details on each of the specific services that are running under those filters I applied, which was the mobile applications. You'll see different optimization types. So the things that we can affect, and you'll see, terminate, which means just turn off flatlined workloads, things that are actually still running, but are not using essentially, according to the policy, the resources that have been given to them. Modernize, as you expect, moving to newer, more powerful instances to save money. The ones that are always most interesting are optimal family recommendations. You'll see modernize, optimal family, downsize, or even upsize to different. It essentially means that you're changing families, that we want to move to a family that is better suited to match that application demand. So in a case like this here, I've highlighted one specific recommendation for this column 523. This is an optimal family sizing recommendation. We're going to move from a compute optimized workload to a general purpose. So an M6i, that's a new Intel chipset. I'll just move across here and have a closer look at, what's it telling me to. It'll look at the predicted uptime. It will see whether or not that workload is covered by an RI, standard RI, something that can't be converted. If it is, we don't want to make a recommendation to change that. You basically be optimizing yourself out of RI coverage. But with savings plans, depending on the type, and with convertible RIs, a lot of times, you can convert those things. An idea of what the savings impact is, the details around the effort level. What is effort level? So that essentially is, how hard is it going to be to actually make this change? In some cases, it could be, different levels of IOPS, different storage types, different hypervisors, even chipsets. So an effort level of low might be that's not going to take a lot from an automation process to actually make this change. In this case, we're moving into a different family, newer generation. There are other types of recommendations that might produce different things. And so, a moderate recommendation might be one where, hey, I want to have a closer look at that. Maybe that's not something that I can easily automate today. And then there's additional metrics here around CPUs, the benchmarks, again, the relative capabilities of those systems. We're going from one to another. Am I gaining power? Am I losing power, so to speak? But again, this whole concept, when we look at the resource utilization, is the before and after. This is the key kind of information that a customer or a business owner is going to want to see. So to Chuck's point earlier, the recommendations will pull in all the history and build a predicted 24-hour window using these 5-minute samples, so we call them hourly quartiles, of a day in a life. What does this workload look like on a typical or predicted day? And what it's going to look like when we move, in this case, to that M6I. So your before and after, blue before, green after. We do that for every single workload. You'll see them here. So busiest day is also important. Some customers might say, well, I want to look at the last 93 days as an example. And I'm going to make my recommendation based on its busiest day in there. So a very conservative kind of recommendation. In this case, we're well below the established thresholds established by policy. And so this is all very useful kind of information for a business owner to say, well, can I make this right? Can I make this happen? Some of our customers, though, don't like to use this interface. They might be more comfortable. It's not that they don't like the interface. It's just, hey, I'm comfortable using my BI tooling, or I just want to see this report once in a while or through an ITSM ticket. So the nice thing is every recommendation that we have has called an app owner report or an impact analysis report. By clicking on any of these hyperlinks, you'll pull up that application owner report, which basically gets into the details of what I just showed. And this is the kind of artifact that can be attached to an ITSM ticket or some sort of an approval process that says, what are you going to do to my instance here? What are you going to do to the application running on this instance? And so all that evidence in terms of the policy that's being used, who does it belong to, the recommendations of before and after, what were they running on the existing instance, what's your cost impact look like, that effort level detail. So all that information is included. So we're very transparent in terms of, what we expose to folks that are trying to decide whether or not this is going to be something that is going to impact my application, or as a reasonable person, is Chuck's point, will I make that recommend or will I make that that change? From an automation perspective, I think it's important as well. Just the whole, what I just showed you was, this is the human readable version. The machine readable version is something I can show right here. So here's a Terraform template. This is an Azure example, and not to get too technical here, but when Chuck talked earlier about these micro purchases, when you have these templates, whether it be something like Terraform in this case, CloudFormation or Ansible or some other configuration management or infrastructure as code tool, a lot of times those micro purchases are hard coded in here. So we might have a recommendation that says, hey, change this off to something else. This is a compute optimized, I think it's 16 core VM in Azure. Maybe it's something different. It's a general purpose or something we're going to change to. But if you don't make the change within the template, next time someone actually launches this service again or refreshes it, it's going to come back as its previous version. So, you may be optimized for a very short term, but if you don't actually build this into your DevOps pipeline, you're going to be, reverting back all the time. So what we do, instead of having customers hard code this, the ability to actually say, let's call the Densify API, and Densify, you tell me what this thing should be. And maybe the answer is going to be, well, I don't have enough workload, so I'm going to use that fallback workload type you defined, and maybe it's that standard F16S, or some other type of workload size like the rest of the infrastructure. But the idea being that if I have a better recommendation over time, this thing is going to become optimized forever. So, forever optimized, optimization as code as opposed to infrastructure as code by doing it this way. And we can do this for the infrastructure that we're looking at in the cloud, also for containers infrastructure as well. I'm sure there's questions that are popping in, and we'll address those in just a moment. I just wanted to show one other component here. The containers, as Chuck mentioned, is a really important part. We're seeing more and more of our customers deploying hundreds, if not thousands of these things into their environments, transforming from on-prem into containers infrastructure. So the same kind of optimization that we do in the public cloud and for VMware, we do for containers as well. For containers running in Kubernetes, no matter where that is in the public cloud or on-prem through OpenShift, VMware Tanzu, what have you. So similar kind of interface and ability to kind of Well, to definitely view, what am I analyzing and how well am I sizing that infrastructure today? Again, green being just right. Upsize, downsize, sizing from unspecified. That's a big problem. We see in a lot of cases where customers are just letting, kernel do that for them, and running into problems is by not specifying because they have no clue typically, or just going to say, I'll let the environment size that for me. The data component, again, this is not a full-blown containers webinar. I think we've done a separate one on that one just recently, and there'll be more coming in the new year. But in terms of the ability to view this infrastructure in a logical way, same kind of way of looking at how well are you doing sizing this infrastructure, the ability to filter down using these tags or labels. Most importantly, I'm just going to give a quick view of this, which is really cool. This new way of visualizing how well are you doing sizing your containers infrastructure. And say we might look at, say, just requests, CPU and memory requests. Call this is histogram capability, and what it allows us to do is see where's the spread in terms of how well you're sizing the infrastructure. In this case, for CPU requests, you can see there's a fair bit of there's a lot of sizing happening where we're more than 5 times oversubscribed in terms of the amount of CPU, and there is some risk in terms of undersizing these settings. On the memory side, you can see it's even worse in terms of undersizing, and anything in this area, as you can see, is there's a termination risk. The Kubernetes is going to kill those containers because of, say, a memkill situation. And other areas where there's just a fair bit of just oversizing happening. And so, again, this is not a view into the container. We're going to have some dedicated webinars around this, but we think this is an incredible way to really visualize how are you doing sizing this infrastructure. And if you've only got 50 containers running, maybe this is not a big problem for you. For a lot of our customers, the ability to visualize how well are they doing this, and what's the overall impact on their environments. In some cases, it could be thousands of millicores or cores of infrastructure and gigabytes where they are sizing this incorrectly and running into all kinds of performance. And
every environment we look at looks like this. And sometimes we hear, well, we're the platform owners, we just let the app teams do whatever they want. Okay, but they're making a significant mess of infrastructure. At some point, that comes home to roost. So
certainly the impact on these environments, like you said, there's no overcommit of memory or CPU in these environments. So when you size it wrong, the impact is happening on your infrastructure as a service, your EC2, your VMs, or your auto-scaling groups. So again, just from a high level, just a little taste in terms of what we're doing and visualizing and the ability to actually correct and optimize these environments. This is what we do, and these are the kinds of results you could expect out of densify environments. So I'm going to turn this back over to you, Chuck, because we've got a few minutes left.
All right. Thank you. I've got just a few wrap-up slides here. We should have them up. So thanks, Andy. Thanks for showing that. I think it brought light to the themes that we were just speaking about. I wanted to mention to the audience something called Intel Cloud Optimizer. Intel is making Densify available for qualifying companies on an annual basis at no charge. Basically, Intel is making this available to customers just as a benefit of being an Intel customer. And for most organizations in the cloud, you are an Intel customer because a huge portion of the standard cloud instances available in all 3 of the major clouds are powered by Intel. This is a program that got started in the last few months, will go into the new year. And it is no strings attached, funded by Intel. So we encourage you to reach out to us. You can reach to us on the contact form to inquire as to whether your company might fit this program. And we're happy to talk to you about it. We've been very engaged with Intel, as I said, as well, making sure that the analytics, along with their help, tell you exactly how to optimize your use of what are very expensive resources. Their model is that they spend billions of dollars developing the best CPUs in the world. You spend millions of dollars running software and powering your business. They just want to help you do that better. That's basically the proposition. We have one more question, and I'll go to some resources here in a second. We're really interested in whether you'd like to hear from us, and you can say no, just browsing, or that you would like to talk to us. The poll is there. Encourage you to go, and I'm sure many of you already know about these resources from the FinOps Foundation. They're a great resource with respect to these topics. And the last point I will make as we go to questions is that you can really think of Densify as a central brain that doesn't compete or conflict with anything in your stack. It doesn't compete with your FinOps program or the investments there. It just ensures that you have lower bills that show up in those environments. So think of us like an optimizer brain. Think of things like the Intel program as a very cost-effective way of bringing this to your infrastructure. And I think that concludes our content. If you have any questions, we're happy to have them. There are a couple here, but also invite you to follow us and consume our content. We put a lot of these webinars up on YouTube. Also, there's a great white paper on the top right specific to these themes and overcoming barriers that organizations have in implementing these types of solutions. So a quick question here, or rather a question I will address quickly. Someone's asking how Densify is priced. Well, if you take advantage of the Intel Cloud Optimizer, it is not priced. It's free. So that's the first answer. If you don't do that, we generally in the cloud base our pricing on the number of workloads that you're optimizing. We don't make it a percentage of your bill. We think that's a bit of a moral hazard. We count up the number of things that you're optimizing, and we charge you on that scale basis. The larger your scale, the lower your price per instance goes. With containers, it's a bit different. We rate that against the number of cores that are in the CPU cores that are in the infrastructure that you're managing. And it's data that's readily available. It's simple math, but again, related to the size of the infrastructure you're managing. That's the way we price. And the great thing about the fact that we are SaaS delivered is that we can, with you, deploy these analytics in really a matter of minutes and get you set up in a way where you can see your own infrastructure through this lens. And we invite you to check that out as a possibility as well. Andy, thanks for your time today. Thank you all for attending, and look forward to seeing or speaking to you at some point in the future. Thank you.
Yes, thanks everyone. Take care.